star of the show is a crane unlike anything Montana's ever seen before. This giant machine stretches 400 feet into the air and weighs more than 1 million pounds, believed to be the largest crane ever used in the state.
Across Russia's coastlines, colossal cranes are reshaping the horizon.
That these cranes have, you're just left with a feeling that this is going to be something that I was very proud of being a part of.
They swing 1,000-ton blocks through the air like toys, building the ships, reactors, and platforms of a new industrial age.
Standing here at the very center of this reactor that could quite literally change the world is a really powerful reminder of just how impactful the construction industry can be.
From twin giants that lift ship sections the size of apartment buildings, to a floating behemoth that hauls entire oil platforms across the Caspian, to a crawler so powerful it raised a nuclear reactor's heart. These are the machines behind Russia's most ambitious builds. The Goliaths of Bolshoi Cayman. Under the gray waters of Bolshoi Kamenn Bay, carved deep into Russia's Far East coastline, lies a man-made hollow so immense that it feels less like a dock and more like a buried stadium. Its floor stretches more than 1,590 feet long. Its walls stand about 374 feet apart, and it drops nearly 46 feet deep, enough to swallow the midsection of an oil tanker whole. Rising above that gap are two colossal orange steel frames that dominate the skyline. These are Zvezda's twin Goliath gantry cranes. Each one can lift roughly 1,200 tons. Each tower is close to 400 feet high, and each spans about 620 feet from leg to leg. They are the machines that turn enormous chunks of ships into floating giants, hoisting blocks so massive they look like apartment buildings gliding through the air. Zvezda shipbuilding complex stands in the small coastal town of Bolshoi Kamenn, facing Vladivostok across the bay. It is Russia's largest and most modern shipyard, an industrial project meant to give the country a way to build the kinds of massive ships it once had to buy or contract abroad. The plan from the start was to construct large, clean-burning crude oil tankers, build gas carriers ready for freezing northern routes, produce heavy offshore parts for rigs and platforms, and prepare for future ice-class ships and Arctic icebreakers. None of that could happen without a dry dock large enough to hold gigantic hull sections and cranes strong enough to move them with precision. The dock provides the space. The Goliaths make that space work. The top beam, stretching about 620 feet across, serves as the runway for wheeled trolleys that slide from side to side, carrying the hooks along its entire width.
The Konecranes Goliath is capable of moving around 30 meters a minute. Think about lifting 1 million kilograms and moving 1.5 feet every second.
With a span wider than a football field, the trolley can place any section exactly where it's needed, while the entire crane rolls forward or backward on steel rails that run the dock's full length. That combination of motions, rolling, sliding, lowering, lets a shipyard assemble massive hulls the way a child snaps together Legos. The first rose above the open assembly area. The second was erected over the new dry dock and finished in mid-August 2019. Assembling the second Goliath, raising its vast beam, setting the legs, and locking the pieces took only about 20 days. That may sound long, but for a machine that size, built on a foggy, windswept coast under strict safety rules, it was lightning fast. The second unit wasn't a simple copy either. Engineers redesigned the lifting gear to match Zvezda's large block construction style, where enormous pre-outfitted sections are joined together instead of being welded plate by plate. The journey to bring these cranes to Russia began years earlier. In March 2016, Zvezda signed a deal with Nantong Cosco Heavy Industry in China, better known as Cheek. The package included the 2 Goliath cranes, plus smaller ones rated for 320 tons and 100 tons. Each Goliath was shipped in huge sections aboard a special heavy lift vessel, complete with all the temporary rigs needed for unloading and assembly. Moving it in one piece was impossible. Nothing that big can travel by land or sea fully assembled. Once the shipment reached Bolshoi Cayman, crews laid out the parts on shore, legs, beams, trolleys, rails, then slowly lifted the giant frame into place. The top beam rose first, the legs swung up to meet it, and everything came together in a precise manner. The overall height reaches about 443 feet when you include the smaller service cranes on top. Operators take an elevator for most of the climb, then finish the last stretch by ladder, a small daily workout before every shift. That climb takes several minutes each way. but it comes with a view that few others on Earth can claim. The yard even held a flag-raising ceremony when the second Goliath was completed, hoisting the Russian flag to the very top. So what exactly do these titans lift? Let's start with Aframax crude tankers, the mid-sized clean fuel ships that dominate modern oil transport. Instead of being built from single plates, they're constructed from enormous blocks that already have walls, decks, pipes, and cables inside. A mid-body block for one of these tankers can be as tall as a house, as wide as the full hull, and as heavy as several locomotives combined. The 1,200-ton limit of the Goliath cranes matches these blocks perfectly, allowing crews to lift and set them in just a few huge pieces. Fewer seams mean fewer welds, and fewer welds mean less time spent inspecting or aligning decks and bulkheads later. The crane's twin hoists and stiff beams keep. The blocks level mid-air so they settle smoothly into position without bending. The same rule applies to gas carriers and ice-class hulls meant for frigid seas. These vessels have tall, heavy modules with pre-installed machinery and insulated tanks. Lifting them safely demands generous clearance under the beam and enough side-to-side reach so that no equipment catches on anything below. That's exactly why Zvezda's dry dock was sized so precisely. Supporting the Goliaths is an entire ecosystem of smaller cranes. The same 2016 order that delivered the Goliaths also brought in 320-ton gantry cranes and 100-ton portal cranes. Those handle the middleweight jobs, sub-blocks, heavy plates, outfitting modules, moving them into position so the big hooks never sit idle waiting. The result is a production flow without bottlenecks. From small sections to full hull blocks, everything arrives on time at the dry dock. The 1,200-ton rating also shows careful balance. A heavier crane could lift more, but its structure would grow thicker and its hook height lower. Lighter would mean less reach. Since the dock already spans about 374 feet, the Goliath had to be tall enough to clear high modules, yet strong enough to lift them. The chosen capacity provides both reach and clearance. It's the sweet spot between power and precision. Big enough to move anything they build, but not so oversized that it blocks its own path. The Caspian workhorse. A wide, flat deck sits low in the water at Astrakhan, where the Volga River spills into the Caspian Sea. On it stands a steel frame shaped like a giant letter A, towering over the deck like a gate built for titans. Hanging from that frame is a hook big enough to fit a small car, and strong enough to lift what an entire train could carry. The machine is called Volga. It's a floating crane, a river-sea heavyweight built to move 1,000-ton loads where no road or railway can. It doesn't sail on its own. Tugboats push and guide it from one job to the next. But once it's in position, the barge holds steady, adjusts itself by inches and lowers steel with calm, surgical precision. Every motion counts, because a single mistake here could cost millions. The Volga is a pontoon crane, basically a big, rectangular barge with a fixed steel boom made for brute strength, not speed. Its main hook can lift about 1,700 short tons, which is more than 3 million pounds in one pull. A second hook handles around 276 short tons for lighter jobs. The barge itself stretches about 282 feet long and about 112 feet wide, drawing just over 13 feet of water. That shallow draft is the key. It means the crane can travel up the Volga's shallow stretches to reach inland shipyards, then head back toward the Caspian for offshore lifts. The hull carries an Ice 1 class mark, meaning its steel and systems are reinforced for work in cold seasons when ice thickens across the river. Fully loaded, it weighs around 11,800 short tons. Unlike the tall tower cranes seen in cities, this one doesn't spin on a turntable. Its boom is fixed. When the hook needs to line up over a target, the entire barge moves slowly and precisely. 8 massive winches sit across the deck, each strong enough to pull about 88 short tons of force. On their drums, they carry miles of thick steel cable, enough to let the Volga move itself, one careful pull at a time. The operator at the control desk watches the readouts that show how much tension is on each cable, adjusting them in tiny steps to keep the hook hanging perfectly straight. Beneath the barge, 4 steerable propellers give just enough push for small, delicate movements when the water is calm. The whole vessel crawls along at only about 7 miles an hour. Because it's a river-sea vessel, The Volga has clear limits that define how and where it can work. It can lift loads safely when the waves are up to around 4 feet high, and the wind stays moderate, conditions that might feel bumpy but still safe. For traveling between sites, it can handle seas with waves as high as 13 feet, but it must stay within about 100 miles of a safe harbor and never more than 200 miles between protected stops. Anchors and ropes complete the system. 2 heavy haul anchors hang at the back, each weighing close to 9 short tons, and smaller anchors sit at the front. 6 more mooring winches, 4 at the bow and 2 at the stern, help the barge tie up to docks or other vessels. When the crane is on the job, all 8 positioning winches pull against anchors spread out in a circle around the site. By easing one line and tightening another, the operator can make the barge slide just a few feet in any direction without calling a tug. The Volga's biggest test came in 2009 during the construction of Lukoil's first offshore platforms in the North Caspian Sea. The job took place at the Yuri-Korchagin field, and it involved 2 enormous lifts. First, the crew used the crane to lower a steel support base weighing about 1,300 short tons onto the seabed. Days later, they returned to lift and place the topside section, about 1,760 short tons, onto that base. It was a performance of pure coordination. The crew added extra anchors for stability, used the steerable propellers for fine control, and completed both lifts exactly as planned. A perfect record for an operation that would have challenged any offshore crane. In the years that followed, the Volga stayed busy all along the Volga River. In 2019, it helped assemble the hulls of 2 new chemical tankers, lifting 8 major sections between March and July, 2 bows and 2 sterns for each vessel. These massive pieces were far too heavy and tall to move by road, and even factory gantry cranes couldn't handle their size. But for the Volga, it was business as usual. By 2021, the Volga was back in the Caspian Sea for another Lukoil project, the Valery Grafer field. It lifted a 1,000-ton module onto a transport barge and later installed a 1,200-ton frame beneath a deck offshore. Every system on board is designed for long, independent operations far from shore. 2 main diesel generators of about 500 kilowatts each power the winches, thrusters, and onboard systems, backed by a smaller 320 kilowatt unit. The barge carries enough fuel and oil for about 20 days of work and enough food and supplies for 10. That gives the crew the freedom to wait for the perfect weather window before attempting a lift. And then came the story that caught the world's attention. In May 2018, Russian strongman Mikhail Koklyaev put on a show at Astrakhan. In front of a cheering crowd and rolling cameras, he pulled the moored Volga just over 7 feet in 2 minutes, setting a national record. The vessel weighed about 6,500 tons, its full loaded weight with fuel, gear, and ballast. The rise and fall of PK-700. A wide, flat barge sat moored in Sevastopol's southern bay, its deck dominated by a tall steel frame and a massive hook built to lift ship sections weighing as much as small buildings. The name painted on its hull was PK-700 Grigory Prosyankin. It was a new Russian floating crane still under construction, meant for work that ordinary ports couldn't handle. It didn't move on its own. Tugboats would push it from job to job. But once secured in place, it was designed to lift up to about 770 short tons and set them down with inch-by-inch accuracy. The design came from CDB Coral, a long-established engineering bureau in Sevastopol, known for building floating cranes for shipyards and ports across Russia and the former Soviet Union. Coral's portfolio stretches back decades, with models ranging from 100-ton harbor cranes to sea cranes that can lift over 1,000 tons. The PK-700's hull measured about 243 feet long and 106 feet wide, with sidewalls just over 21 feet high. When traveling, it drew about 9 2/3 feet of water, but when fully loaded for work, it sat closer to 13 feet deep. The barge weighed around 6,900 short tons when light, and nearly 8,600 short tons in full working trim. Its deck could carry an additional 2,200 short tons, allowing it to transport large ship sections or steel structures. Inside were bunks for 14 crew members, powered by 3 main generators of 1,000 kilowatts each, roughly 4,000 horsepower combined, and 2 smaller backup units. Even its name carried meaning. Grigory Prosyankin had been a leading figure in Soviet shipbuilding, helping develop the nuclear-powered fleet and later becoming an honored citizen in Severodvinsk. Naming the crane after him tied a modern engineering project to a man who helped shape the nation's maritime industry. The Sevmorzavod shipyard that built it had decades of history making similar cranes. For years, Sevmorzavod produced dozens of floating cranes, from the Bogatyr class to Slava Sevastopolya, and even larger ones like Vityaz. The yard's records claim more than 70 such cranes, with lifting capacities ranging from 50 to 1,600 tons. The PK-700 was meant to carry that legacy into the present, a heavy-duty floating crane built for naval construction, shipyard lifts, and moving massive structures across the Black Sea. The plan looked simple on paper, but progress was slow. Koral designed the crane, and Sevmorzavod laid its keel in November of 2018. Years later, the project remained unfinished. By August of 2023, reports said the shipyard was considering cutting the partially built hull into 3 large sections and shipping them north through rivers and canals to Severodvinsk, where the Sevmash yard could finish it. Then came the day it made headlines. On the afternoon of October 27, 2025, the unfinished PK-700 suddenly rolled onto its side during work near the quay in Southern Bay. The governor of Sevastopol reported 2 deaths and more than 20 injuries. As of early November 2025, investigators had not published their findings. Still, the general ways a floating crane can capsize are well understood. When a crane lifts a heavy load, its center of gravity rises and shifts toward the weight. If the platform leans too far and the buoyancy can't bring it back, it rolls. If there's water sloshing around inside partially filled ballast tanks, that water rushes to the lower side and makes the lean worse. A sudden shove, from wind on the tall frame or from a tugboat pulling too hard, can push it even further. And when a crane is still unfinished, with its ballast controls and emergency systems not yet calibrated, the safety margin can shrink dangerously. Once a crane goes over, the recovery process is always the same. Divers first secure the area and check for leaks or hazards. Then, salvage crews start planning how to right the hull. That can mean pumping air into sealed compartments, attaching lift bags, or using another crane barge to help pull it upright. Afterward, engineers inspect every part for damage, checking the pedestal, the A-frame, and the deckhouse for bends, cracks, or broken welds. The class authority then orders a full stability review before the crane can ever work again. The 2,000-ton crawler at a nuclear site. Under the wide, cold sky of the Gulf of Finland, a flat pad of reinforced ground came alive one September morning with a crawler crane as big as a building creeping into place to lift something no human hands could ever move. This was no ordinary construction job. It was the first major lift for a new nuclear reactor at Sosnovyy Bor, roughly 40 miles west of St. Petersburg. The project is Leningrad Nuclear Power Plant 2, where Units 3 and 4 are new Viver 1200 reactors built to run safely and provide power for decades. On September 9, 2025, crews began a lift that would last about 16 hours. The goal was to raise and set the first steel ring for the inner shell of the Unit 3 reactor building. The work demanded a machine so large and stable that every move had to be measured in inches and minutes. The part itself was enormous. A welded steel cylinder roughly 33 feet tall, 144 feet wide, and weighing about 322,000 pounds before rigging. Add the heavy slings, shackles, and spreader bars, and the total weight on the hook came close to 500,000 pounds. Before the live lift, the team rehearsed the entire process with a dummy load of 500 tons, raising it 4 inches off the ground and holding it there for 10 minutes. Only after the engineers confirmed every gauge and pressure reading stayed within safe limits did they move on to the real pick. The giant that handled it was a Zoomlion ZCC 32,000 crawler crane, a China-built heavyweight assembled and operated in Russia by Titan II, Rosatom's main contractor. Its official class rating is 2,000 metric tons, but the figure that really matters isn't the raw tons. It's the lifting moment, the measure of how much turning force the crane can resist before tipping. On this crawler, the maximum lifting moment is about 31,500 ton-meters, or roughly 228 million pound-feet. That is pure leverage. the invisible muscle that lets a machine this size lift a building's worth of steel without folding on itself. Its boom sections can be configured for power or reach. In heavy mode, the boom runs from about 177 to roughly 354 feet long. In lighter setups, it can stretch beyond 500 feet when distance matters more than raw weight. Behind the crane sits a giant superlift counterweight that can weigh nearly 1,984,000 pounds. Even with all that mass, the crawler's pressure on the ground is only about 34 pounds per square inch, low enough that it doesn't crush the reinforced pad beneath it. Its movement is deliberate and slow, topping out around half a mile per hour. The arrival and assembly of such a machine was a logistical marathon. It didn't roll into Russia whole. It arrived in pieces from Changsha, China, about 64 low-bed truckloads in total. Titan II's mechanization team began putting it together right away. The base alone, the turntable, power pack, and crossbeams already weighed more than 124 tons before counterweights were added. Once the massive side weights and superlift frame went on, the total topped 800 tons. A separate Manitowoc crawler crane, rated for 750 tons, helped raise the boom and attach the hook block, which itself weighed around 75,000 pounds. By August 26, 2025, the Zoom Lion was fully assembled, days ahead of schedule. Engineers then ran control tests and system checks so the national regulator could approve it for nuclear site work. That ring, the first of several that will make up the reactor's inner shell, was assembled on a separate jig in 24 curved segments. Welders joined the pieces into a full circle before the crane ever approached. The ring's job is structural and symbolic. It forms the skeleton that future layers of concrete and rebar will lock around, creating the containment vessel that protects the reactor core. Because of that role, it must be perfectly round, perfectly level, and perfectly seated. Wind posed the biggest natural threat. A ring more than 140 feet across behaves like a sail, catching gusts that can twist the entire crane. Crews watched the forecasts closely. When conditions steadied, the operation began, raising the steel ring inch by inch, slewing slowly over the building, and lowering it into a circular form lined with guide rails. The process took about 16 hours from first lift to final placement. Once the ring touched down, welders and fitters moved in immediately to lock it into position with temporary braces. The Zoom Lion, ZCC 32000 that handled this job, is no stranger to Rosatom's projects. Titan II has deployed identical machines at other nuclear builds, including Egypt's El Dabaa plant. Their Cairo team assembled the same model 25 days ahead of plan, proving its reliability for precision nuclear lifts. Using the same equipment across multiple sites also means every operator, rigger, and engineer works from a shared playbook, a huge advantage when the tolerance for error is nearly zero. From this point forward, Sosnovyj Bor's skyline will keep changing. More rings will rise. Concrete will climb around them layer by layer. The dome, when it comes, will be another heavy lift spectacle of its own. And the same Zoom Lion crawler, or perhaps its twin, will handle that job too, because nothing else combines reach, balance, and power in quite the same way. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.